Okay, so here's the formula of how to write an exponential function. So you can see how everything's labeled. A being your initial amount. What are you starting with? Are you starting with $50? Are you starting with 100 people? What are you starting with? Your initial amount. You always have a 1 here, and then you choose plus or minus. You're going to use the plus if it's an increase. You're going to use the subtraction if it's a decrease. R is your rate. Rate is usually a percent, so 20%, 35%, but you never put a percent into a formula. You always put the decimal. So if I had 20%, what would R be? 0.2, right? If I had 8%, what would R be? 0.08. You move the decimal 2 places to the left. T is time, and time is going to be relevant to the problem. Are we talking 5 minutes? Are we talking 5 hours, 5 years, 5 hops? What are we talking about? Okay? And then your answer is then your final amount. What do you want it to be in that amount of time? Okay? So that's the formula we're using. I wrote it down over there so we can reference. Okay, so when you read these problems, you need to kind of pick out what's my A, what's my R, what's my T. So find a bank account balance if the account starts with $100, has an annual rate of 4%, and the money left in the account for after 12 years. Okay, so looking at my formula, what's my A? What's my initial amount? $100. Okay, is this $100 increasing or decreasing? Increasing, so I add, right? And I'm going to add by what? 0.04. Yep. Okay. Now, I want to know what is this final amount after 12 years. So what's T? 12. So I pull out my calculator and I can plug that in and solve it. So I'd have 100 parenthesis 1 plus 0.04 to the 12th power, and after 12 years, I'll have $160.10. So there's my answer. All right, dollar sign, make sure it's labeled. Okay, let's try another one. In 1985, there was 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? So what did I start with? What's my initial amount? 285. What I do plus or minus? Plus, I'm increasing cell phone subscribers. And I'm increasing by how much? 0.75, 75%. Now I need to know how many years went by from 85 to 94. 9 years. So again, you take your calculator, you're going to plug that in. So 285, 1 plus 0.75 to the 9. So 43,871. 0.99, right? Subscribers.
What if it's people would be rounded up?
Right. So good. This, if you want to do decimal approximation, that's fine. I'm not picky about that in Algebra 2. But higher level math, since you're talking people, you would actually round down in this problem because you can't make up 1/10 of a person. So really, my answer should be 43,871 subscribers. You would round down when you're talking things. If you're talking hours or years, then you would round up into the next year. All right, let's try another one. Bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only 1 bacteria, which can double every hour, how many bacteria will we have at the end of 1 day? So my initial amount is 1 bacteria. Okay, here's the question of the day. What percent is doubling? Doubling is 100%, which is 1. So it'd be like that. And then how many hours in a day? 24. Put that in my calculator. So I could do, if I wanted to use some mental math, I could just say 2 to the 24th power. So I get, let's see, 16,777,216 bacteria. Okay, so here's the other way to use the formula when you want to find T. You buy a new computer for $2,100. That's my initial amount, right? That's what I bought the computer for, $2,100. It decreases, so minus, it decreases by 50% annually. That's 0.5. When, that means time, when will the computer have a value of $600? So I want to know, when does this equal $600? So I don't know time. I don't know that. Okay? So to find that on a graph, if you were to graph this, you would graph 600, which is just going to be a line, y equals 600. You would graph this decreasing, right, model, this decay model, which looks something like this. Where they intersect, that is how long it takes. What is t? What value is t here when y is 600? That's what you're finding. So you use a graphing calculator. Right? So you put out a graphing calculator, right? And you want to go to your y equals, and you need to put one of these into y1 and one of those into y2. For me, I'm just going to put 600 into y1, and I'm going to put 2100, 1 minus 0.5 to the t, to the x, right, into y2. So as long, and you don't have to have 600 y1 as long as you just separate it. One of them into y1 and one of them into y2. It doesn't matter. Graph, okay, see where this is intersecting. If you don't see it on your graph, you're going to have to fix your window. Whatever this answer is here, 600, that's going to relate to what your y max should be. So since I want my answer to be 600, let's go a little bit more than 600 and do 700 on my y max. And then I can graph. And I have to see the intersection in order to find the intersection. So just like we did minimas and maximas, you go second trace, and you have this number 5 intersect. So you go down there, push enter. You're going to get first curve question mark. So you get close to your intersection. You're going to push enter. It jumps to your second curve, and you want to move till it's close to the intersection. Push enter, and then guess, you'll push enter a third time, and it'll click that intersection and see how y is 600. My x is 1.81. So I could say 1.81 years, which would be in the second year. In the second year, it'll depreciate to $600. All right, you drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. How long until you have 10 milligrams of caffeine? What's my initial amount? 120. Am I doing 1 plus or 1 minus? And I'm minusing by 12%, 0.12. I don't know t, that's what I'm solving for, how long, and I want the answer to be 10. So again, you put one into the y1, the other into y2. So I'd go clear that out, 10, and you're going to have to change your window here because your numbers aren't as big as the last problem. Right? So on my window, I would want my y max instead of 700. My answer is 10, so a little bit more than 10 would be 15. So my y max on this one, I'd only want to be 15. And then I can graph, and I see it. good. If not, I'd have to probably change a little bit more. So then I go second trace, intersect, first curve, it's blinking on that first curve there, get close, push enter, it automatically jumps to the second curve, I just need to get close, push enter, and then guess, you push enter a third time, and when y is 10, it's been 19.44 hours. Right? That's why you don't drink caffeine after 2 p.m., right? Takes a long time to leave your body. All right, the foundation of your house has 1,200 termites. Gross. The termites grow at a rate of 2.4% per day. How long until the number of termites double? So what's my initial amount? 1,200, and it's growing, so that's a plus. And I don't know time, that's what I'm solving for. And what would double be? 2,400. So I get my graphing calculator. And in my, let's see, y1, I would put 2,400. In my y2, 1,200. 1 plus 0.024 to the x. And I'm going to have to change my window because, look, my answer is 2,400. That means my y max needs to be a little bit more than that. So I would make my y max 2,600. And then graph, see where I'm at. And I'm really over here on the right side. I would want, if I want to go farther to the right, I increase my x max. So window, x max, I'd increase, let's go 40. And that just gives me a little bit better picture. Second trace, intersect, get close to that intersection, enter, get close to that intersection, enter. And it's 29.23. And it's hours, right? So in the 30th hour, after 30 hours, my termites have doubled.